Chapter 10, Video 2, Mineral Resources. Mineral resources are finite and exhaustible. Mineral deposits are not evenly distributed over the Earth because they are formed only under special geological conditions. An ore deposit is a mineral deposit that can be economically mined at a certain time and place with a certain technology. Tech advances change when and where this can happen. For example, deep sea mining operations are becoming economically viable. Currently, the best potential deep sea site is the Solwara 1 project in the waters off of Papua New Guinea. This site is a high-grade copper-gold resource with a first seafloor massive sulfide SMS resource. The Solwara 1 project is located at 1,600 meters deep in the Bismarck Sea, New Ireland Providence. The mine uses remotely operated underwater vehicle technology, and Nautilus Minerals Incorporated is the first company of its kind to announce plans to begin full-scale undersea excavation of mineral deposits. Production is expected to start in any day now. Also, reserves are identified or deposits that have yet to be exploited. So we have mineral deposits and reserves. Here's some pictures from the Solwara website. On the schematic on the left, you can see the mining rig that's floating above the seabed floor, and it's probably a little small here, but you can see down here that there are these underwater excavators that are being used. Currently, these underwater drills have been doing exploration since about 10 years now. And here's an artist rendering of a mining rig that would be used and remote controlled. All the control is up here, and then the minerals are pumped up to the ship. Excluding war, mining can be one of the most environmentally destructive activities undertaken by humans. Minings and tailings have destroyed many millions of acres. Thousands of acres around smelters are dead zones from toxic emissions. Each year, the material moved by humans in mining may be twice the amount of sediment carried by all the world's rivers out to the ocean. These are some examples of damage from past mining operations. In Figure 1 is a picture of acid mine drainage outside Pittsburgh, Pennsylvania. Sulfur that's exposed in coal tailings is transformed into sulfuric acid by sulfur oxidizing bacteria, lowering the pH of the stream to the point where nothing else can grow. Abandoned mine drainage is water that is polluted from contact with mining activity and normally associated with coal mining. AMD is a common form of water pollution in Pennsylvania and other states where vast amounts of mining took place in the past. There are several issues with abandoned mines that impact water quality. Acid mine drainage, which I just mentioned, is most prevalent, and this is a picture of that right here. Alkaline mine drainage. This typically occurs when calcite or dolomite is present. And metal mine drainage. High levels of lead or other metals drain from these abandoned mines. Acid mine drainage is the formation and movement of highly acidic water rich in heavy metals. This acidic water forms through the chemical reactions of surface water and shallow subsurface water with rocks that contain sulfur-bearing minerals, resulting in sulfuric acid. The reaction itself is done by bacteria. Heavy metals can be leached from rocks that come in contact with the acid, a process that may be substantially enhanced by bacterial action. The resulting fluids may be toxic, and when mixed with groundwater, surface water, and soil, may have harmful effects on humans, animals, and plants. In Figure 2 is a picture of the Berkeley Pit from the closed Butte Copper Mine in Butte, Montana. 1 mile long, half-mile wide, 1,780 feet deep hole. This operated as a mine from 1955 to 1982. The pit is now filled with acidic water. Lurking within that water is a plethora of heavy metals and toxic chemicals, including copper, iron, arsenic, cadmium, zinc, and sulfuric acid. The iron-rich water near the surface is reddish, yielding to a vibrant lime green hue not far below the surface where copper concentrations are higher. The water level in the pit is constantly rising at the rate of approximately 0.7 feet per month. As of April 2012, the water level was 5,301 feet above sea level. At 5,410 feet, the critical water level, the pit water would contaminate nearby groundwater of the Butte Valley, home to more than 30,000 people. Through groundwater flows, such contamination could potentially spread through the Clark Fork River, the largest drainage in western Montana. Now they have to pump and treat the rising pit water, so this does not happen. Since the Industrial Revolution, mineral use has increased at very high rates. Raw material has leveled off in the United States and Western Europe since the 1970s, but developing countries will need large amounts as they industrialize. Humans are currently depleting their mineral resources quite rapidly. The effects of environmental degradation and pollution may curtail mineral exploitation before the deposits are actually exhausted. The economics of mineral consumption. Minerals, including the precious metals, are artificially cheap. Over the past several decades, known reserves for many metals and other substances have grown as fast as or faster than production. The current price frequently includes only extraction costs and not the cost of land, ore, and externalities, such as pollution and contamination of water. Governments have traditionally subsidized mineral production for several reasons. 1. They want to exploit currency to reduce international debt. 2. They want to have strong economic development in the country. And 3. It's seen as a source of national security. If you have your own minerals, you don't have to get them from somewhere else. There are two basic stages for dealing with mineral scarcity. You can increase the supply by locating new ore deposits or recycling old material, although this can actually be difficult. Or you can decrease the demand by finding substitutes or alternatives, or eliminating the need through technology or lifestyle change. The production of more durable goods that can be used for a longer period of time is one way to reduce the demand for mineral resources. This, of course, means that goods would be more expensive and retailers might not make as much money. Creating better designs involving upcycling or the recycling of components of durable goods is another way to reduce the demand for mineral resources. In this section of this chapter, we determined what a mineral deposit was and what a reserve is. We also talked about the Solwara project and why this might be happening now. We also talked about why mining is environmentally destructive. We should be able to give examples of that. Why do the authors claim that minerals are artificially cheap? Why do governments subsidize mineral production? And how might scarcity be dealt with?